Hi everybody. Today we're going to start to look at loops. So the first thing I want to do is walk through this slides presentation with you. I'm going to attach a copy as well, so that way if you want you can go back at any time. The best way to view this is as a presentation, so you can see the animations that are happening. If you have any questions at all with any of this, please feel free to email me or stop by Math Lab. Okay, so let's get started. Okay, there we go. So today we're going to talk about lists, we talked about lists last time. Now we're going to start to talk about loops. So I know some of this will say with a partner, do these things. Obviously this year's a little different. So unfortunately you're working on your own, but again, stop by and see me anytime. So right now you have one command, move forward. This command moves the robot, which is this piece right here. Move this out of the way. One space forward. So think about what the program would look like to move the robot to the purple box. If you want, you can pause the video now. All right, so you'd have to move forward once, twice, 3 times, 4 times. So if you looked at that program, it would look like that. And you can see that it's very repetitive. So this would be an instance where we could use a loop. So the first type of loop that we're going to look at is called the while loop. Basically, the while loop takes place while something is happening. Okay? So instead of writing the same code and being repetitive, we can use these loops. So again, while something is true, the code in the while loop runs over and over until that thing is no longer true. So for example, this is going to keep going around, and then once this is no longer true, then it will exit the loop. So let's take a look at an example. So I know that the wording might be a little bit weird at first. JavaScript can look a little bit confusing, but we're going to work on understanding what that is today. So var steps equals 0. That means that you're on step 0, so your starting point. Once you move forward once, then you're on step 1. Move forward again, you're on step 2, and so on. So what this loop says is while your steps are less than 4. So when you're starting at 0, 1, 2, 3, 4, once you hit 4, you're no longer less than 4. So this thing would no longer be true, and you would stop moving forward. So let's take a look. So we're on step 0, which is less than 4, so we move forward. Now, this piece right here is important because what's happening is as you move forward, it increases your step by 1. If you didn't have that, it would never increase your steps. You'd stay at 0, and it would just be an infinite loop. It would go on forever. All right, so now we move again because we are at step 1. We moved 1 step, basically. That is still less than 4, so we move forward. Now we're on step 2. It's still less than 4. Move forward. Now we're on step 3. Again, it adds to it, which is still less than 4, and we move forward. Now that we're up there, we're on step 4. 4 is not less than itself. So since that's false, now it's time to exit the loop. Okay. Now with this, let's see what happens. Run the program on your board. What happens? Just moving forward like it says. But it goes off the screen. And again, the reason for that is you're missing that step plus there. That means that your steps never increase. So it still thinks you're at 0. So it's always going to be true, and it's going to be an infinite loop. Oh, getting ahead of myself here. Go back. My mouse is very sensitive. Okay. So here's a new program. Or excuse me, a new command. So now we're going to turn right. When you turn right, basically you're just rotating 90 degrees clockwise. All right. So let's take a look at what this program says. You're starting at a step of 0. As long as the steps are less than 4, you're going to move forward and turn right, and you'll add on to the next step. So we're going to move this guy forward, and then it's just going to rotate right. It's not going to move. Okay, so it moved forward and just rotated. All right, now we're on step 1. It's still less than 4. So it moved forward and turned right. Move forward, turn right, and 3 is still less than 4, so we're going to move forward, turn right, and you're back to the beginning again. Again, if you don't have this piece, your round or your steps are not increasing each time. Okay, so the while loop has 3 important parts. A counting variable set to an initial value, which is this here. This is your initial value. And again, it's a variable, so notice it has the var there. The next important part is a Boolean expression which checks the condition of that variable. So it's asking you, are your steps less than, in this case, 4? If so, then you're going to do these things. If not, you're going to exit the loop. And basically, a Boolean expression is just a yes or no question. And then the final thing you need is a statement which increases or decreases the variable that's being checked. All right. If this piece is missing, you're going to create an infinite loop, which we saw. Okay. So next, we're going to look at another type of loop. It's called a for loop. All right. A for loop basically combines them all, simplifies it a little bit. So all of these same things are there. So you have your steps starting at 0. They usually use the letter I, and the reason for that, a loop is an example of an iteration, which is basically just means that it repeats a repetitive portion of an algorithm which repeats a specified number of times until a given condition is met. All right, so there's that piece. It's just simplified a little bit. We want our steps, which again is I, to be less than 4. Same thing. And then we want to increase our steps each time. And if those things are taking place, then we're going to move forward. So this is the same as this, just simplified. And again, this was an example of a while loop. This is an example of a for loop. So those are the same. Again, they commonly use I because of the iteration. Those are the same. Those are the same, and then you move forward. Okay, so here's another new command. Turn left is the same as turn right, except instead of rotating 90 degrees clockwise, you're going to rotate 90 degrees counterclockwise. So let's take a look at one of these examples. So our starting step is 0, and we want to do this until as long as your step is less than 3, and we want to increase it each time by 1. If these things are true, you're going to move forward, rotate to the right, move forward again, and rotate to the left. All right, so let's think about where this will go. If we go forward, rotate, so you'll be facing to the right, move forward, and then rotate to the left, so you'll be facing up. So let's take a look. Rotate, forward, left. And now that's step 1. 1 is still less than 3, so we're going to do it again. Move forward, rotate right, move forward, rotate left. All right, now we're on step 2. 2 is still less than 3, so we're going to move forward, rotate right, move forward, rotate left. Now you're on round 3. 3 is not less than itself. So that means it is time to exit the loop, and you're done. All right, so let's click and see a new example here. So again, we've got our starting step of 0. As long as it's less than or equal to 2. So that means it could be 0, 1, or 2, an increase. So forward, forward, turn right, forward. Okay? Forward, forward, turn right, forward. And 1 is less than 2 or equal to, so we're going to do it again. And 2 is equal to itself, so it still meets that condition. It's still true, so we're going to run it again. And now we're on to round 3. 3 is not less than or equal to 2, so we're exiting the loop. All right. A little bit more here. So again, starting at 0, as long as it's less than 2. So we're really going to do step 0 and step 1. Move forward, turn left again, move forward, move forward. So move forward, turn left. So basically 180 degrees, and move forward twice. We're now on step 1. It's still less than 2. Move forward, left. And you're back to the beginning. Okay. Now, there's some other things that will happen. You could have barriers. Your robot cannot go through those barriers, and it cannot not go through the walls. It has to be in this area. So your new commands can move left, can move right, can move forward, can move backward. All right. So, can move forward. This is true. You can move forward. You can move to the right. Notice it's not rotating. It's just moving that way. You cannot move to the left. You can move backward. You can move forward. You can move to the right. You cannot move to the left because you'd hit a wall. And you cannot move backwards. All right, run the following program. Where will the robot end up? So let's take a look at what we're working with here. Our starting step is 0. We're going to go until it's less than 3. So we're just doing 0, 1, and 2. If we can move to the right, then we're going to turn right and move forward. In this case, can we move to the right? Yes. So we're going to turn right and move forward. So basically rotate and move forward. Then, let's do that. Turn right, move forward. Now it says, if you can move forward, which we could, then you turn left. And then if you can move forward, you move forward, but we can't move forward, so we're not going to. So our step is done. So the barriers and walls sometimes make it so you can't run the full program. All right, so if we can move to the right, we can. We're going to turn right, move forward, turn left, and we'll be able to move forward because the barrier won't be there. So we should end up right here. So we're going to turn right, move forward, turn left, move forward. Now, 2 is less than 3, so we can go again, but let's check. Can we move to the right? No. So we're not going to turn right and move forward. Can we turn left? Let's check it out. All you can do is turn left. All right, because when we were here, we couldn't move to the right, so we skipped this part. We could turn left because it's just a rotation, but since we can't move forward, we're done. And now that 3 is not less than itself, you're going to exit the loop. All right. Just a few more with these. Again, just getting used to how they're written. So again, starting with 0 until less than 4. If we can move forward, we're going to move forward, turn left, and then if we can move forward again, we're going to move forward and then turn right. All right, so let's see. Can we move forward? Yes. So we're going to move forward and turn left. So we'll be facing left. And then because we can move forward again, we'll move forward and turn right. So we should be facing up. Let's see. Now for round 2, we could move forward. So we moved forward. And then if you turn left, you'd be facing this. You wouldn't be able to move forward. So you just turn right. Same thing with this one. So here we could move forward. So we moved forward. We turned to left. Because we could move forward again, we did. And then we turned right. And we went another time just because we were going till your steps were less than 4. So with this, again, we couldn't move forward, so we just turned left. And then we could move forward, so we moved forward and turned right. So basically, you can skip certain parts of those based on what you're working with. So just a few key takeaways from today, and I did make a Google doc that has this information in it for you, all kind of in one spot. The while loop, again, uses a Boolean condition, which is just a yes/no question, to repeatedly run a block of code. If it's true, it runs the block. The process of checking the condition and running the block of code is repeated as long as the Boolean condition remains true. Once the expression becomes false, it will stop. And that's what this looks like. So you start at 0. While that value is less than 3, you're going to do something and increase that count. And then the for loop is a little bit more condensed. It condenses the parts of a while loop into a shorter statement, similar to the while loop. And once the Boolean expression becomes false, the loop ends. All right, the only other thing we talked about is if there's barriers. And again, if there's barriers, maybe you can do part of a program and you can't do another part, but you're still going to continue to try to run the whole program each time until your steps are not true, not meeting that condition anymore. All right, and just remember the term iteration is just another word for a repetitive portion, to repeat. And an infinite loop would occur when an ending condition will never evaluate to false. So remember, if you're not increasing the steps each time, so if it just keeps saying true, 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 you're going to stay in that loop. All right. If it's never true, if it's never false, you'll exit the loop. You won't exit the loop and it'll be infinite. Okay. So I'm going to stop you there. I apologize. I know this was kind of long, but we're going to get some practice in. If you have any questions, stop by the Math Lab. I'm happy to help. Or shoot me an email. Have a great day.